here. Well, aloha. And as you can see, this is different layout. That's why the camera is acting more erratically. And that's also going to be a concern later on, as usual. But for this time, I'm going to probably go in and out checking on the stream itself, not just the camera or any other tools. But we'll see how this goes. If I'm gone, well, you know where I'll be. Just this a little bit more by closing this. Just this to be a little bit more straightened. Let me actually just close this. Alrighty. Well, like the position, the issue that always arises is just if it has issues. Oh, well, as you can see my finger, you can actually read part of it. Well, for mineral and geology and mineralogy, a mineral or mineral species is, broadly speaking, a solid chemical compound with a fairly well-defined chemical composition and a specific crystal structure that occurs naturally in pure form. The geological definition of mineral normally excludes compounds that occur only in living beings. However, some minerals are often biogenic, such as calcite, or are organic compounds in a sense of chemistry, such as melite. Moreover, living beings often synthesize inorganic minerals such as hydroglyphite that also occurs in rocks. Alrighty. Everything's good. It's starting to flicker a lot more now. And close again. And let me look towards. Okay. The camera actually does start flickering, but when a light gets displayed, it starts to act erratic. And that is unfortunate. It also made me think that I should just keep my camera out and just continue to stream without it. Because at least the mic is working. That's always a doozy. But, that's the show. Now let me actually posture myself. See if there's any issues. No, still no. I think it's probably this tea, but or is it just my skin? That's unfortunate because I have these lights there. All good. So yeah, it does look like it is a stream itself. Not per se the camera. After all, it has that effect where you could read part of my screen. Well, that means I'm just gonna keep this off, and I'll check in the next 50 minutes or such. I'll continue on where I left off, and then get this picture right here. Crystals of sandite, nitrolite, anismine, and andron from Mont Saint Hilaire, Quebec, Canada. Hilaire, Saint Hilaire, Quebec, Canada. Alrighty. Hydrosulfite. I mispronounced it, but I'm not gonna beat myself over words that is quite difficult to pronounce to begin with. Anywho, back to this. The concept of mineral is distinct from rock, which is any block, solid, geologic material that is relatively homogeneous at a large enough scale. A rock may consist of one type of mineral or may be an aggregate of two or more different types of minerals, specifically segregated into distinct phases. Some natural substances without a definite crystal structure, such as opal obsidian, are more properly called mineraloids. If a chemical compound occurs naturally with different crystal structures, each structure is considered a different mineral species. Thus, for example, quartz and sulfide are two different minerals consisting of the same compound, silicon dioxide. All this. The National Mineralogical Association (IMA) is generally recognized standard body for the definition of nomenclature of mineral species. As of January 2022, the IMA recognized 5,780 official mineral species out of 5,981 proposed or traditional ones. The chemical composition of a named mineral species may vary somewhat by the inclusion of small amounts of impurities. Specific variants of the species sometimes have conventional or official names of their own. For example, amethyst is a purple variety of the mineral species quartz. It's actually just showcasing how everything is structured in families, into groups, and all that sorts. Some mineral species can have variable proportions of two or more chemical elements that occur at equivalent position in the mineral structure. For example, the formula of McIntyre is given as Fe(Ni)9S8, meaning this affects X, where X is a variable number between 0 and 9. Sometimes a mineral with variable composition is split into separate species more or less arbitrarily forming a mineral group. That is the case of silicates, cax, jigs, seafood, the living group. And this is the 11 people, or 11 group. My mistake. The primary component, Earth's upper mantle. Yeah, it talks a variety of gems and minerals. They could belong in this group, or what's it related to. Besides the essential chemical composition and crystal structure, description of a mineral species usually includes its common physical properties such as a habit, hardness, lustrity, diffetti, color, streak, tendency, cleavage, fracture, parting, specific gravity, magnetism, fluorescency, radioactivity, as well as its taste or smell and its reaction to acid, showing how a mineral can be tested and what properties it has. Minerals are caused by key chemical constituents. The two dominant systems are the Dana classification of the Strunz classification. Silicate minerals comprise approximately 90% of the Earth's crust. Other important mineral groups include the native elements, sulfides, oxides, halcides, carbonites, sulfates, and phosphates. Alrighty. Do you have pictures of them? Yeah. The sulfate minerals are closet minerals. Gotcha. To the oxides, that's how they look. Includes those minerals in which the oxide is bonded or more metal alloys. Now, by pictures alone, it's not great to see. That's why it's always good to have it in person. So me learning about this without prior knowledge would be pretty hard. So Halide minerals are those minerals with a dominant halide anion complex. Halide minerals may also have polyatomic anions. But actually, yeah, go down to these specific ones and compare pictures and how each one is different. Carbonate minerals are those minerals contained in the carbonate ion. Yep. Sulfates. Yeah, it just has this. It doesn't have any further pictures. Let's just do a sneak peek and see if there's any more pictures. Boride with salarosite. Okay. So that would be under sulfites. And phosphate minerals contain the churchofluorinated phosphate. Let's get a sneak peek. And then you have all this contents. Oh yeah. Apatite, phosphate mineral. Alrighty. So by the surface, you can tell the difference. That's where you gotta test all this stuff. So definitions, rocks, ores, and gems, entomology, chemistry, physical properties. Yeah, there's a lot of physical properties. Look at classifications. Astrobiology. I heard of it. Don't know much about it. And then 8 through 13 are just a bunch of resources. See also notes, references, general references, further reading, external links. Yeah, that's a lot. But that goes to show how this topic, mineral on itself, is a lot to bear. So bear with me that, yeah, and even I got a lot to learn. So yeah, minerals. That's the gist of this. This mineral is different from this mineral. Then you have these two that obviously are different, but have similar properties. Now let's go under those definitions. International Mineralogical Association. The International Mineralogical Association has established the following requirements for a substance to be considered a distinct mineral. Alright. It must be a naturally occurring substance formed by natural geological processes on Earth or other extraterrestrial bodies. This excludes compounds directly and exclusively generated by human activity, anthropogenic, or in living beings, biogenic, such as tungsten carbide, urinary calcium oxalate, crystals in plant tissues, and seashells. However, substances which such origins may qualify geological processes were involved in their genesis, as in the case of ebonite, derived from plant material, or tanacrite from bat guano, or aplersite from mine tailings. Hypolithic substances are also excluded, even if they are predicted to occur in inaccessible natural environments such as Earth's core or other planets. Okay, so that's 1. 2. It must be a solid substance in its natural occurrence. A major exception to this rule is naive mercury. It is still classified as a mineral by IMA, even though crystallized only below -39 Celsius because it was included before the current rules were established. Water and carbon dioxide were not considered minerals, even though they are often found as inclusions in other minerals, but water ice is considered a mineral. Yep, it must have a well-defined crystallological structure, or more generally, an ordered atomic arrangement. Alright. This property includes several macroscopic physical properties such as the crystal form, hardness, and cleavage. It excludes ozarkyrite, limonite, obsidian, and many other amorphous, non-crystalline materials that occur in geological contexts. And 4, it must have a fairly well-defined chemical composition. However, certain crystallization substances with a fixed structure by a variety of composition may be considered a single mineral species. A common class of examples are solid solutions such as magnetite, which is mostly a ferrous sulfide with a significant fraction of iron atoms replaced by nickel atoms. Other examples include layer crystals with veritable layer stacking, or crystals that differ only in the regular arrangement of vacancies and substances, substitutions. On the other hand, some substances have a continuous series of composition may be variable split into several minerals. The typical example is the olivine group MgFt SOiO2 and SiO4 or SiO4, who is magnesium rich and iron rich, and end members are considered separate minerals. Phosphorate, phthalate. Okay, the details of the rules are somewhat controversial. For instance, there have been several recent propositions to classify amorphous substances as minerals, but they have not been accepted by the IMA. So just know, well, bear with me, that it's all under one guideline, and it's just to follow as a guideline. It's not written in stone. Well, yeah, there's a lot of properties in defining what is a mineral. Alrighty. It must be naturally occurring substance formed by natural geological processes. Yes. It must be a solid substance in its natural occurrence. So solid. Has to be grow naturally on the Earth or other planets' surface or exterior. It must have a well-defined crystallological structure, or more generally, a order atomic arrangement. Yeah, it doesn't explain it on the arrangement, but it has to have a type of arrangement that is similar to other minerals. If it has the same arrangement as other minerals, it's a mineral. It must have a fairly well-defined chemical composition. However, certain crystallized substances with a fixed structure but variable composition may be considered single mineral species. So I did not know these two, because they could be mixed match, and it looks like that's why it's controversial. That it could be the atomic arrangement of the structure and the chemical composition, so how it was composed and what property it has when compared to other chemicals. And you have large set of gems that are being artificially manufactured that muddles with, is it a gem? Is it a real gem? Same case with minerals. The IMA is also reluctant to accept minerals that occur naturally only in the form of nanoparticles in a few hundred atoms across, but has not defined a minimum crystal size. Some authors require the material to be a stable or metastable solid at room temperature 25 Celsius. However, the IMA only requires for the substances to be stable enough for its structure and composition to be well determined. For example, is recently recognized a naturally occurring hydrate of magnesium sulfate as a mineral, even though it's formed stable only below 2 Celsius. Yeah, I'm just gonna stop here reading everything, because I'm realizing that a lot of these wiki articles are going to talk about the chemistry and some formulas and equations relating to these, and that would be a lot to explain over if I don't have a notepad and to crunch the numbers and also solve everything, because reading it out, it takes more to understand something. So I figured I'm just going to skim through this, going to read most important parts. So for this one, I'm going to skim over because it just tells you general information. So as of January 2022, 5,780 mineral species are approved by the IMA. They are most commonly named after a person, followed by discovery location. Names based on chemical composition or physical properties are two other major groups of mineral name etymologies. Pretty much, that is a thing I could glance at, fastly read myself, and I could just explain. And just able to highlight all this info. Commonly named after a person. CCA. There's a list of minerals named after people. The chemical composition follows name. So I could go through there. After all, whatever I learn, we learn, we can understand on what we've been spending this time at, what we have learned for the day. Most names end in "ite." The exceptions are usually names that were well established before organization of mineralogy as a discipline. For example, gallant and diamond. So yeah, "ite." But it's not always the case. Like diamond doesn't have "ite." Galna doesn't have "ite." Now, biogenic minerals. A topic of contention among geologists and mineralogists have been IM's decision to exclude biological crystal substances. Quote, organisms are capable of forming a diverse array of minerals, some of which cannot be formed inorganically in the biosphere. Skinner, 2005, views all solids potential minerals and includes biominerals and mineral kingdom. Gotcha. Creative biological activities of organizations. Skinner, yep. Skinner also classify element or compound and formless acrylonitrile formed through a biogeochemical processes as a mineral. Alrighty. Recent advances in high-resolution genetics and X-ray absorption spectroscope are providing revelations on the biogeochemical relations between microorganisms and minerals that may shed new light new light on this question. So, on this question, that is the question, I believe. What is a mineral? Especially the more we're understanding, the less we're able to find it. So that's an advantage for our scientists and researchers. Working group on environmental, mineralogical, and geochemistry deals with minerals in the hydrosphere, atmosphere, and biosphere. Their research group scope includes mineral forming microorganisms which exist on nearly every rock, soil, and particle surface spanning the globe. Biochemical cycles that contribute to the formation. Minerals for billions of years, microorganisms can precipitate minerals from solution, contribute to the formation of ore deposits. They can also crystallize into solution minerals. Alright, it's already been around 50 minutes. We'll see how this camera acts. Yeah, it does flicker. Even with my finger. Oh, my knuckles. Yeah, it still flickers. And it flickers way more. I'm staying still. No, I'm not gonna stay still. And yeah, it's overreacting. Well, I guess I got to rearrange the camera. Because it's not the flickering that gets, just me understanding that it can be damaged any further. So, let's see if it gets worse. Oh yeah, back to Skinner's 2005 definition of mineral takes this matter into account by saying that a mineral can be a crystal or amorphous. Yeah, because Diana's classification scheme, so many mineral classes. Gotcha. Oh, yeah, let me read these. These minerals, a subset tubulated in Lowstam 1981, comes around. A 2011 article on defined electrolytes, illuminate iron, copper, alloy is a mineral named in the unique natural symmetry. It is a quasi-ionic crystal. Unlike a true crystal, quasi-crystals are ordered but not periodic. Okay. Yes. Yeah, I mean, we read this here, so part, yeah. Name and publish, yeah. Then we go back talking about Skinner, and then other things that arise. And then after the end, we come from the person who know it all about minerals and gems, Skinners, to Nichols, where he had his own definition. And later on is this article that puts a wrench into new discoveries in this field. So yeah, even that is a big deal. Rocks, ores, and gems. I think the mouse is also. Alright. Even smart items are actually reacting weird, so it does look like worrying about everything is a matter. But worrying about tech having issues and troubleshooting it regularly, it's just like breathing. Whenever you're using tech, it just happens, and just the way life is. Rocks, ores, and gems. A rock is an aggregate of one or more minerals or mineraloids. Some rocks, such as limestone or quartzite, are composed primarily in one mineral. Calcite or aragonite in the case of limestone, and quartz in the latter case. Alright, let me read the quick explanation. Aragonite is a carbonate mineral, one of the three most common naturally occurring crystal forms of calcium carbonate. So we went through that. And, that's the same realm as calcite, where they look pretty similar. However, it's a carbonate mineral. Calcite is a carbonate mineral and the most stable polymorph of calcium carbonate, so it has that chemical composition, but that's pretty much it. In this case, the limestone and quartz in the latter case, other rocks can be defined by relatively abundances of key essential minerals, as a graphite is defined by the proportion of quartz, alkali feldspar, and pelagioclase feldspar. The other minerals in the rocks are termed accessory minerals and do not greatly affect the bulk composition of the rocks. Rocks can be composed of entirely non-mineral material. Coal is a sedimentary rock composed primarily of organically derived carbon. Alrighty. Let's see how much I have left. Oh, okay. Nah, I'm not gonna skim through this. I want to get back to here and go through these pictures, because this is the best thing I could learn. Visually seeing how each minerals are different. All in all, that's why a lot of people love minerals, crystals, gems, and all that sort, because they love how they look. Durability, yeah, to an extent, but it's not like they use it as tools nowadays. It's more as fashion itself. Jewelry is a fashionable garment to wear, especially on necklaces, earrings, such. It's all because of how we look. So I take it that is the aim of just looking at all these pictures, is just to see, oh, I like skits, because it looks like a sponge with some rotting mold. But this mold looks like it's going to brush on my skin and carve it. It's a little haunting thing about it, but yeah. The skits is a metaphoric rock characterized by an abundance of flat-fine minerals. In this example, the rock has prominent selenite phorophyte blasts as large as 3 centimeters. 1.2 inches. Well, here's the time. Let's see if this thing is going to act. Oh, okay. Now it's overreacting way too much. Without further ado, I'm gonna change this position. It's gonna be a different layout. A different layout as usual. But, back. I am back, and without further ado, aloha. See you.